Mastering Microservices Testing Strategy. No one owns our microservices KPIs, and it's killing our ops. Who within our organization is responsible for establishing and tracking the key performance indicators, KPIs, for our microservices, and what tools or methodologies do they use to effectively monitor and report on these metrics in order to ensure operational excellence? As I delve into the realm of microservices testing strategy, I'm reminded of a profound truth. The pursuit of operational excellence is a journey, not a destination. It's a mindset that permeates every aspect of an organization, and its implementation requires a deep understanding of the interconnectedness of people, processes, and technology. In my experience, the key to operational excellence lies in embracing a culture of experimentation, where curiosity and creativity are encouraged, and failure is seen as an opportunity for growth. It's about fostering an environment where individuals can thrive, and their collective efforts culminate in a symphony of efficiency and effectiveness. Let me illustrate this with a case study. Imagine a company, which we'll call Eclipse, that has recently transitioned to a microservices architecture. Eclipse faces a daunting task, ensuring the seamless integration and operation of multiple services, each with its own unique characteristics and dependencies. To tackle this challenge, Eclipse's leadership recognizes the need for a unified testing strategy that encompasses the entire microservices ecosystem. They assemble a cross-functional team, comprising representatives from development, quality assurance, and operations. This team is tasked with developing a comprehensive testing strategy that guarantees operational excellence. The team begins by identifying the critical components of their microservices architecture. They focus on the interfaces, APIs, and data flows between services, as well as the underlying infrastructure and network connectivity. This exercise helps them pinpoint the potential bottlenecks and areas of vulnerability. Next, they design a multi-layered testing approach, comprising unit tests, integration tests, and end-to-end tests. This strategy allows them to validate individual services, scrutinize interactions between services, and simulate real-world usage scenarios. However, the team soon realizes that testing microservices in isolation is only half the battle. They need to replicate real-world conditions, accounting for variables like network latency, data volumes, and user traffic. To accomplish this, they employ service virtualization tools, which enable them to simulate the behavior of dependent services and create realistic test environments. As they develop and refine their testing strategy, the team recognizes the importance of automating tests and integrating them into the continuous integration and continuous deployment (CI/CD) pipeline. This allows them to detect defects and anomalies early on, reducing the likelihood of downstream problems and ensuring that only high-quality services are deployed to production. To measure the effectiveness of their testing strategy, the team establishes key performance indicators, KPIs, that focus on service reliability, response time, and error rates. They leverage monitoring tools, such as Datadog and Prometheus, to collect and analyze performance data, providing insights that inform their optimization efforts. Throughout this journey, I thought about the complexity of microservices architecture and the need for a holistic testing strategy that acknowledges the intricate relationships between services. I felt a sense of excitement as the Eclipse team explored the possibilities of service virtualization and automation, and I was struck by the importance of balancing technical capabilities with business objectives. As Eclipse continues to refine its testing strategy, the organization begins to reap the benefits of operational excellence. Services become more stable, reliable, and efficient, leading to improved customer satisfaction and reduced maintenance costs. The Eclipse team's efforts have created a ripple effect, inspiring other teams to adopt similar approaches and fostering a culture of innovation and collaboration. This story highlights the importance of embracing a mindset of operational excellence, where individuals work together to create a harmonious system that is greater than the sum of its parts. By adopting a comprehensive testing strategy that accounts for the complexities of microservices architecture, organizations like Eclipse can achieve new heights of efficiency, effectiveness, and customer satisfaction. In the context of microservices testing strategy, operational excellence is a critical aspect that ensures the reliability, security, and efficiency of microservices in production. To establish and track key performance indicators, KPIs, for our microservices, a dedicated team or individual should be responsible for overseeing this function. This team, often referred to as the Site Reliability Engineering (SRE) team, is tasked with ensuring the smooth operation of microservices and identifying areas for improvement. The SRE team uses a combination of tools and methodologies to effectively monitor and report on KPIs. Some of the key tools and methodologies used by the SRE team include 1. Monitoring tools. The SRE team uses monitoring tools such as Prometheus, Grafana, and New Relic to collect and analyze data on microservice performance, latency, and error rates. These tools provide real-time insights into system performance, allowing the team to quickly identify issues and take corrective action. 2. Service level indicators, SLIs, are quantitative measures of service quality, such as uptime, latency, and error rates. The SRE team defines and tracks SLIs for each microservice, providing a clear understanding of service performance and identifying areas for improvement. 3. Service level objectives, SLOs, are target values for SLIs, specifying the desired level of service quality. For example, an SLO might specify that a microservice should be available 99% of the time. The SRE team uses SLOs to set clear goals for service quality and to measure progress towards achieving those goals. 4. Error budgets. Error budgets are a forward-looking approach to reliability, where the SRE team allocates a budget for errors or downtime and works to stay within that budget. This approach encourages the team to prioritize reliability and take proactive steps to prevent errors. 5. Data analytics. The SRE team uses data analytics tools such as Google BigQuery or Amazon Redshift to analyze large datasets and identify trends and patterns in microservice performance. This analysis helps the team to identify areas for improvement and optimize system performance. 6. Automated testing. The SRE team uses automated testing tools, such as JUnit or PyUnit, to ensure that microservices meet the required standards for performance, security, and reliability. Automated testing helps to catch errors early in the development cycle, reducing the likelihood of errors in production. 7. Continuous integration and continuous deployment. CI/CD. The SRE team uses CI/CD pipelines to automate the build, test, and deployment of microservices. CI/CD pipelines help to ensure that changes are thoroughly tested and validated before being deployed to production, reducing the risk of errors and downtime. 8. Blameless post-mortem analysis. When errors do occur, the SRE team conducts blameless post-mortem analyses to identify the root cause of the issue and implement corrective actions. This approach encourages the team to focus on solving the problem rather than assigning blame. 9. Collaboration and communication. The SRE team collaborates closely with development teams, product owners, and other stakeholders to ensure that everyone is aligned on service quality goals and KPIs. Regular communication and reporting help to ensure that everyone is aware of service performance and any issues that need to be addressed. 10. Continuous learning and improvement. The SRE team continuously reviews and refines their tools, methodologies, and practices to ensure that they are using the most effective approaches to achieve operational excellence. This commitment to continuous learning and improvement helps to ensure that the team stays ahead of the curve and adapts to changing requirements and technologies. By using these tools and methodologies, the SRE team can effectively monitor and report on KPIs, ensuring that microservices meet the required standards for performance, security, and reliability. This focus on operational excellence enables the organization to deliver high-quality services that meet the needs of customers and users, while also reducing the risk of errors downtime, and other issues.